So we're going to do some questions on speed, distance, time, average speed, and all associated rearrangements of that particular formula. So we've got a question here that talks about a cycle race, and it's telling us some distance, and it talks about average speed. So again, we'd underline average speed is important, and we'd ask ourselves, what do we know about that? Well, we know that average speed is equal to total distance. So average speed is equal to total distance divided by the total time taken. And it's kind of important that you remember that, because the classic definition of speed is speed equals distance over time, and lots of people like using the science triangles to help you remember what to do. If you want distance, cover it up, those are next to each other, so times them. If you want time, cover it up, those are above each other, so divide them, and so forth. But the average speed formula is quite popular in exams, and it's about requiring you to remember it's about the total distance for a journey divided by the total time taken. Similar principle, but it's important we get that subtle difference. Okay, so it's told us this average speed, so we know that the average speed is 15.12 miles per hour. And we've been told that the distance was 3,069.25 miles, and we want to know the time for the whole journey, total time. So that's what we've got as a kind of a scenario, but then we read the question carefully, and it says we need to estimate this answer. So as soon as the question starts talking about estimating, then we start thinking, well, we can round these to nice-ish numbers. So we can see here that 15 is associated with 30. Two 15s make 30. So a sensible estimate would be to make that 15 and to make this 3,000 and 3,000 to make it simple. We could have made it 3,060 because we realised that also has a connection with 15, and then that's divided by the total time. Because we want to know what the total time is, then we would rearrange this formula. So total time times 15 is equal to 3,000. So the total time is equal to 3,000 divided by 15, and because we've that was divide, that's why we timesed, and this was timesing, so that's why we divided this side. And we can see that to do this calculation it would have been on a non-calculated paper. So 30 divided by 15 is 2, and then we're left with 100, so 200. So we know this is roughly 200 hours. It says estimate how many days. Well, it said it was going to cycle for roughly 8 hours a day. So we know that we're going to then do number of days equals 200 divided by 8. And what we've got to remember, if this was a non-calculator question, then we need to remember that divide by 8 is the same as halving, halving and halving again. So this becomes 100 over 4, it becomes 50 over 2, which becomes 25. So we recognise that it's going to take 25 days as an estimate. Okay, not too far off. As I say, we could have made that 3,060 because that would also have divided by 15 reasonably nicely, and then that would have given us a slightly different answer here. But this is a nice estimate to get. The question went on, and it talked about he trained for the race, so his average speed actually increases. So the average speed has actually increased. So whereas we divided by 15, we're now going to divide by something bigger. So therefore the answer will get less. So when it says how does this affect your answer to part A, we're going to say the number of days will be less. Okay, so that's how that question works. Another question here that involves speed, distance, time, and we've got some information here, and it talks about average speed. Work out Ollie's average for his total drive. Okay, so let's have a look what happened. Quite often it's useful to draw out a little sketch of the journey. So he drove from Liverpool to Manchester, and then he drove to Sheffield. So 56 kilometres was that, and to get from Manchester to Sheffield, 61 kilometres. It says his average speed from Liverpool to Manchester was 70 kilometres an hour, so we've got 70 kilometres per hour, and he took 75 minutes to drive from Manchester to Sheffield. So from here it was 75 minutes. So we can see already that this has got a different set of units. But then we remember that this question talks about average speed, and it wants you to calculate average speed. So what we need to remember about the formula for average speed is that it's the total distance divided by the total time taken. So have we got enough information? Do we know the total distance? Well, yeah, we do know the total distance. We know it's 56 plus 61. Do we know the total time? Well, we know part of it. We know this bit took 75 minutes, so it looks like we need to work out the time for this part of the journey. So we can see that from Liverpool to Manchester, using speed is equal to distance divided by time. Then we can rearrange that. Now you either like using the speed, distance, time triangle, and you say to yourself, well, I want time, so I'm going to do distance divided by speed. Or you know that this says divide, so you bring the times across, the time across by timesing, and then the s will come across by dividing. Either way, you end up with the time being equal to the distance divided by the speed. So here we've got a distance of 56, and we're dividing by 70. And that's going to give us a fraction of an hour. So this is going to give us, well, 56 divided by 7 is 8, and then divided by 10 is 0.8. So that's going to be 0.8 hours. Now what we need to remember is that this was in minutes, so therefore we need to turn this into minutes. So we're going to be doing 0.8 times 60, because we recognise there are 60 minutes in 1 hour. So that's a total of 48 minutes. So now we look back at the calculation we're trying to do. Do we know the total time? Yeah, we know the total time is 75 minutes plus 48. So we get our calculator, and we've got a fraction, so we can press our fraction key, and we've got 56 plus 61 divided by 75 plus 48. Okay, so that's given us 39 over 41. Now that's going to be miles, no it's not, it's kilometres, we're dealing with kilometres in this question, so it's going to be kilometres per minute. Because what we need to remember with units is that this was in kilometres and this was in minutes. So we've got kilometres per minute, but we realise that the question, when we look at the answer line, the question wanted the answer in kilometres per hour. So we need to finish this question off by timesing by 60 to get the number of minutes into the hours. So we end up timesing by 60, and that gave us an answer of, well, we changed that, so 57. So we got 57.1. So that equals 57.1 kilometres per hour. So that would be the answer to that question. Okay, so again, the importance of remembering that average speed has a slightly different thought than speed. You have to think about the total distance divided by the total time. Okay, so the question goes on. It talks about Janie drove from Barnsley to York. Janie's average speed was 80. Her average speed from Leeds to York was. Janie said that her average speed from Barnsley can be found by the mean of those two. Is she correct? Well, we need to recognise that it would be correct if the total distances between the two towns was the same. We just don't know that. So what we've got to say here is not necessarily. It depends if the two towns are of the same distance apart. So, and the two parts of her journey, well, it would suggest from Barnsley to Leeds she was travelling much faster, so it's likely to be a motorway or something. So, and when it says, what does it tell you about the two parts of her journey? Well, it suggests that different roads, different types of roads allow faster or slower journey. So, for example, motorway versus A roads. Okay, so that's the answer to that question. So hopefully that makes sense. Okay, so we've got another question here that involves cycling, and two people cycled along the same 50-kilometre route, so there's our distance. So we know that the distance is 50 kilometres, and the time for James was 2.5 hours. So the time for James is 2.5 hours, and James and Peter cycled at constant speeds. Okay, so we can assume that if we divide these two, we get James's speed. So James's speed is equal to 50 divided by 2.5, which is 20 kilometres per hour. Okay, so that's some of the marks of the question. It said Peter started to cycle 5 minutes after James, and Peter caught up when they had both cycled 15 kilometres. Okay, so we know, right, okay, so we know that James, for 15 kilometres, takes, well, if he's travelling at 20 kilometres per hour, then it's going to be time is equal to distance divided by speed. Again, we get that from the fact that the speed, distance, time triangle tells us that time is distance over speed. So we know the distance was 15 kilometres, and we know that the speed was 20 kilometres per hour, so consistent units, so we can divide them. 15 over 20 is 3/4, so it's 3/4 of an hour. So 3/4 of an hour. So in other words, 45 minutes. Okay, so that's everything we know about James for that 15 kilometres and speed and everything else. So then we've got Peter. He caught up 15 kilometres. Okay, so Peter started 5 minutes after James. So James is going to get caught by Peter. So Peter's time is 40 minutes. And his distance is 15 kilometres, the same. So Peter's speed, again, same formula, it's distance over time. So distance over time for speed. So that's going to be 15 over 40 minutes. Well, we know that 40 minutes, because we need to compare like with like, and the answer line has kilometres per hour. So we need to turn the 40 minutes into hours. Well, we should recognise that 40 minutes is 2/3 of an hour. So here we're doing 15 divided by 2/3, so that we're dealing with hours and kilometres. And we know division by fractions is the same as multiplying by the reciprocal of the fraction we're dividing by. So that gives us 45 over 2, so 22.5 kilometres per hour. So that's the answer to that question. Okay, so it's a case of breaking it down into different things. As you see a calculation that can be done, then do it. Work your way through the question. The question said work out Peter's speed. So we've got to that stage where we have worked out the speed. We've made sure the units are consistent because the answer line wanted kilometres per hour. And that was a question worth 5 marks. So hence the reason there's quite a bit of work to do. Okay, so we've got a plane. It's travelling at a speed of 213 miles per hour. Work out an estimate for the number of seconds. Okay, so there's an inconsistency because we've got 1 unit in hours and we've got an answer that we need in seconds, and we want to travel 1 mile. Okay, so this would suggest that we need to work out what happens for 1 mile, so how long it takes for 1 mile. So if we know it's 213 miles, it's an estimate, remember, so we'll say it's approximately 200 miles is equivalent to 3,600 seconds. So 1 mile, 3,600 seconds, guys, remember, came from the fact that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So we do 60 times 60 to get the number of seconds, which was 3,600. So to get the 200 to there, we had to divide by 200. So we're going to divide this by 200. And we can see that if we divide this by 100 and then we divide this by 100, we end up doing 36 divided by 2. So it's 18 seconds. So it says work out an estimate for the number of seconds the plane travels, takes to travel 1 mile. Well, if 200 miles is 3,600 seconds, 1 mile will be about 18 seconds as an estimate. The question goes on and asks, is your answer an underestimate or an overestimate? Well, we rounded the number of miles down, and so we divided the hour by 200. If we divided by 213, it would have made the answer slightly less, so therefore our hours is an estimate, an overestimate. So we rounded to 200 miles. When we really needed to divide by 213, which means real answer would be less. So something like that should get you the mark. Okay, so that's another example of a question involving speed. Okay, so we've got another question. Lara's a skier. She completes a race in a particular time and a race at a particular distance. So she assumes her average speed is the same for each race. So basically we need to work out the speed for this race. Well, again, speed, distance, time, and we know that average speed is equal to the total distance. So we know that average speed is the total distance divided by the total time. So in this case we've got first race, we've got a total distance of 475 meters and we've got a time of 1 minute 54 seconds. Probably easier to work that in seconds first, and then we'll get to convert it later back into minutes and so forth. So we've got 475 meters divided by, well, we've got to remember that 1 minute is 60 seconds, so it's going to be 114 seconds. So 475 divided by 114, so we get 4.17 meters per second. Okay, so that's the speed, the average speed she takes for the first race. It says we're going to assume that that is true for her second race. So we've got a 700 meter race. So we know for the second race that the average speed is 4.16 recurring. Okay, so we've got that in our calculator already. And we know that equals a distance of 700 meters, and what we want is the time. So we rearrange this. Okay, so we've got to work out the time, so we rearrange this to be time, because we take that across by timesing, then that comes back across by dividing, so it's going to be 700 divided by 4.16 recurring. Okay, so we've got 700 divide by our original answer, so that's 168. So this is equal to 168 seconds. The answer line wanted the answer in minutes and seconds, so we know that 1 minute is 60 seconds, 2 minutes is 120 seconds, so we've got 2 minutes and 48 seconds. Okay, so that's how that question could be answered. The question goes on and talks about Lara's average speed actually increases the further she goes. So in other words, she's travelling faster. So basically, travelling faster, so time would reduce. Okay, so that's that question. So that's a bit of practice on speed, distance, time and average speed and its connotations. Hopefully of use, guys.